Welcome to G Fun Facts Online. To predict the future, you might look at a crystal ball. But what if I told you that to understand the future of our planet's climate, we need to look millions of miles away to the dormant volcanoes of Mars? It sounds like science fiction, but the fiery past of the red planet is giving us critical clues about Earth's own climate history, and more importantly, how to prepare for what's next. 4 billion years ago, both Earth and Mars were young, geologically active worlds. But while Earth has constantly repaved its surface through plate tectonics, Mars, which lacks this process, basically froze in time, making it a planetary time capsule. And what a capsule it is! Just look at the Tharsis region, a volcanic plateau bigger than the continental United States, hosting Olympus Mons, the largest volcano in the solar system. Scientists believe eruptions from these giants spewed enough carbon dioxide and water vapor to create a thick, warm atmosphere, possibly allowing liquid water to flow and carve the valleys we still see today. An early, more Earth-like Mars. But here's where the plot thickens. Other evidence points to early Mars being a cold, icy world. So which is it? A warm oasis or a frozen desert? The answer might lie where fire meets ice. On Earth, when volcanoes erupt under glaciers, they create unique, flat-topped mountains called tuyas. And guess what? We've found very similar structures on Mars. This suggests volcanic activity was punching through ancient Martian ice sheets, creating temporary pockets of warmth and water. It's a complex picture of dynamic interaction between ice and fire. So how does this relate back home? Well, volcanoes are major climate players on Earth too, but in a complicated way. A massive eruption like Mount Pinatubo in 1991 can actually cool the planet for a couple of years by throwing sunlight-reflecting particles into the stratosphere. But over millions of years, sustained volcanism, like the Deccan Traps in India 66 million years ago, can pump out enough CO2 to cause long-term global warming. Now, let's be crystal clear. Current human activities release far more carbon dioxide than all of Earth's volcanoes combined. That's a crucial fact. To test these Martian theories, scientists need a stand-in for Mars here on Earth, and they found one: Iceland. With its cold climate and volcanic landscape, it's our planet's best Mars impersonator. We've even tested Mars rovers there. Amazingly, data from the Curiosity rover in Mars Gale crater shows rocks that are strikingly similar to those found in Iceland. This suggests the climate of early Mars might have been a lot like Iceland's is today. Cold, dry, but still able to support liquid water. This research isn't just academic. It's about planetary defense. We spend a lot of time worrying about asteroid impacts, but experts warn that the risk of a massive, climate-altering volcanic eruption is hundreds of times higher, and we are, quote, woefully underprepared. Such an event could cripple global supply chains and food security. And here's another twist. There's growing evidence that our own changing climate, by melting glaciers, could actually trigger more earthquakes and volcanic eruptions. It's a complex feedback loop. So, by studying the silent, colossal volcanoes of Mars, we're doing more than just planetary science. We're gaining a profound understanding of the powerful forces that shape worlds, including our own. The red planet, in its dormant state, is offering us a vital lesson. Its frozen volcanoes are a stark reminder of how a climate can change, and they might just hold the key to ensuring the future of our vibrant, living Earth. Thanks for tuning in to G Fun Facts Online.